is that I will be teaching you a new topic, and this topic is not related to anything you learned before. So I know that, I've been working right now for 7 weeks on stuff which is pretty much connected to what you learned last year, like total station, and here is my XYZ. Then what can I do with my XYZ? I can do a map, or I can find a volume. We've covered this already. So today, I'm very excited to teach you something called photogrammetry. And I want to get some feeling that anybody, if you guys learn or knew or know the word photogrammetry before, can you show your hands if you learn anything or know anything about photogrammetry? Hmm. Is that uh, that's Matthew? Matthew, did you learn anything about photogrammetry before?
Just a little bit.
Okay, so I'm very excited. At least I have one before nobody ever learned photogrammetry before they hit my class. So I'm very excited, and I'm hopefully I will teach you more than what you know about photogrammetry. And so photogrammetry is, look at the name, photogrammetry. If we split the name as two words, photo and grammetry, you will see looks like we will deal with some photos. So we will start here. We have agenda, and we have lots of information to give to you within, the probably the next 2 weeks. We will talk about photogrammetry and types of photogrammetry, what kind of applications, what good and bad about photogrammetry. We talked about very important misconception, which is map against photos. Are they the same or they are different things? We also cover something called orthophoto, and we will also talk about the history of photogrammetry and how does it work. And then we will do an exercise in class using a software to process some photogrammetry data and create a fantastic, fantastic product. Okay, now photogrammetry, before I start, to be honest, I would like to just to tell you something about photogrammetry. So photogrammetry is one of the surveying techniques, okay? I'm not sure if I start recording. Let's see. Yes. So photogrammetry is a surveying technique, just like total station and GPS and other surveying technique. Um, and ultimately, photogrammetry will give you your map, okay? But in a different fashion than what you learn until, like, for in the first year, okay? And just to be clear, like photogrammetry is, I guess it's one of the oldest surveying technique. So if we talk about timeline, like for example, GPS, do you know how old GPS? Like how old, how many years did we use GPS? You will be surprised if I tell you GPS, the idea back in 1970s, but the GPS was not in full operation until the year of 2000. Okay, so to be honest, GPS is in the market for us to use is only 20 years. That's not really too long ago. We just use GPS for only 20 years. Total station, I guess it's the same idea, probably around the 50s. There was an invention of EGM, like allows you to measure distance electronically. So how many years? Oh my God, this is, and I think the invention of the first total station, not EDM, because total station is an integration of EDM plus other things, So the first total station was roughly around 70s. So how many years? Probably 50 years. So total station is older than GPS. Now, if you put on the time scale photogrammetry, can anybody guess how old photogrammetry is? Is it 20 or 50 or 70 years? Anybody can guess that?
At the beginning of the last century?
Yes, it's actually, remember, we are in the right now we are in the 21st century. Okay, so the photogrammetry started when the camera was invented. And if you do some research and see, there was so many trials about the invention of the cameras, but it's around mid 19th century. So to be honest, like photogrammetry is around for about the last 170 years. Huh? And you can see right now, 170 years that photogrammetry, GPS is only 20 years, total station is 50 years. So it looks like photogrammetry is an old guy, huh? And so photogrammetry, I can tell you, which you will get to know, it was kind of a very standard method. People, they know about it, they used it, but it was kind of put in one corner. One corner, it was kind of very, very, very limited for use. It was used only in one domain called aerial application. So we fly an aircraft, we have a camera, and then we take a photo, some photos uh, of the Earth, and then we're able to use photogrammetry to build a map or 3D model for the Earth. So that was ever since. It was a very, very old application. However, I'm going to share with you something that in 2020, photogrammetry, it just became viral. It is just simply went outside this corner and become everywhere. So almost like everyone right now is using photogrammetry. And if you wonder why this is happening, what all of a sudden, although photogrammetry is around for the last 170 years, why? What happened? What happened? What shakes the world and make photogrammetry is being used in everywhere? I'll give you a few things. One of them, I use this picture here, and I know it will look funny for you. I know that for sure. When you look at this picture here, probably you will laugh. Okay? Take your time, look at my screen, and see what's happening here. You guys see what's happening here? So just something that probably you guys are so young and you don't really appreciate the what's happening in the world, the advancement. I'm not that old. I'm not 100 years old, but I came through the transition from old technology to the new technology. I can tell you, I had my bachelor degree in engineering. I didn't have a computer. Can you tell me whoever in this time right now in KG doesn't have a computer in KG? Okay, so the thing is, things are getting rapidly changing, and technology is doing that for us. Huh? Look at this. The picture here is 1956. This is a 5 megabyte hard disk, 5 megabyte. And I can tell you right now, you can take a photo with your camera, a single photo, one photo with your camera, and it will be more than 5 megabyte. So you can see we get like we will store our one photo in a kind of a room size machine. Okay, in 2020 we have those micro SD, which is an SD in 2020. It's 1 terabyte, and I know some of you will say, okay, what is the relationship between this and photogrammetry? Okay, you will see as we progress in our class here, photogrammetry, it requires a power of computation, and I don't know how to tell you what was my first computer that I bought in 1996 when I became a full qualified engineer. Oh my God. The hard disk was probably a few megabytes. And, I myself did some training in 1991 on a computer called XT, where there is no operating system. The operating system was something called DOS. Anybody knows about DOS, DOS? I doubt. DOS, DOS.
I know. I just
I
started
know
my
it.
first programming with that.
Yeah, so DOS is probably it's the first operating system. It's not Windows based. There's nothing you can see. It's only black, dull screen where you just have to type in all your commands, like copy file. See how easy a little kid right now can copy files. 25 years ago, before Windows, anybody used DOS to copy file or delete file? You have to write a heck of a command called delete file. Where is the file name? And you add some parameters. Right now, that is kind of a piece of cake, okay? So anyway, I don't want to spend the whole class talking about this one because I am my age and my generation simply went from hand things that we do things by hand to things that we use by computer. I can tell you my capstone project, in 1996. It was in highway design. I simply had to draw 36 A0, A0. You know what is A0 size? A0 uh, with my hand, just to have those drawing table white that I have a long ruler, which I had to draw all the curves and all the straight lines, and that was fun. And then after I graduate, then I learned about something called AutoCAD, which you can copy, save as. Just remember, if you make a mistake on a hand drawn drawing, what you do if you make a mistake? Simply you have to start over and do it over again. If you make a mistake in AutoCAD, you do undo. You type in U and then hit enter and you undo your mistake. And you can copy very fast. Anyway, I'm really fascinated by the technology. I feel it. Probably none of you guys feel the technology because you were born in an era where everything is ready for you. Anyway, so photogrammetry, it requires a lot of calculations, okay? And years ago, it takes forever to do the calculation. And today, you can do calculation very fast and very, very efficient. And that's why photogrammetry uses all those technological advancement and then went out of this corner and tried to rule and come back to life. That's one thing. But the other thing is drones. Drones right now, what's the relationship between drones and photogrammetry? Any relationship between drones and photogrammetry? Very simple. Before, we have only one option to fly an aircraft and then have a big camera installed an aircraft and flies on top of one area. And then this limits the use of photogrammetry to only aerial application. Because in an aircraft, how many of you have aircraft? How many of you? Aircraft. None, huh? None. You're not that rich. But how many of you could have a drone if you spare some money? How many of you can afford to buy a drone? I guess all of us. I myself had a drone, but I sold it before the pandemic because I have no use for it right now. And so I had a drone and it was a couple of $1,000s. Okay. This is something that you can afford right now. And drone, it is a platform. It can fly, not really as high as an aircraft, but it still can fly and can take an aerial image at elevation of probably 50 or 100 or 150 meter. And we have a cheap, affordable platform. Before, you have to rent an aircraft, very expensive. You have to hire a pilot, very expensive. You have to have a very expensive camera. Right now, everything is within a very affordable budget. Okay. And one thing, I'm not going to say it right now, but it will come our way when we progress on photogrammetry, which is simply the artificial intelligence, the image processing. Those are something that did not exist 20 years ago. Now our computer becomes so intelligent, becomes so smart. Can I ask you one question? Like, do you guys probably, you have a camera, even you have a cell phone camera. You have a cell phone, right? That's right? Can anybody confirm you have a cell phone?
Yes.
Yes.
Okay, your cell phone has a camera, is that right?
Yes,
Yes.
that's right.
Yes.
Okay, so did you ever take a picture with your camera? Yes, you did. When you take a picture with your camera, does it ever draw a box around faces or recognize faces?
It can, yeah.
It can. Did you ever ask yourself how come a machine will see the face and say, okay, here is a face. I'm gonna draw a circle around this face. I mean, probably you've never thought about this question, but this question is a very complicated question, by the way. It requires some sort of intelligence. I know that a little kid can do that. And maybe you will see your father. Maybe if you show, if you have a son or something, and you show the picture of you to your son, maybe it will point to you and say, okay, here is my dad, right? But the thing is, this is for machines to do that is not an easy task. It requires a lot of calculation and it needs some sort of intelligence. And those things, those tools were not available for us. Okay, anyway, I will leave it at this point. All I wanted to say within those 10 minutes is that photogrammetry is not new. It has been around for 170 years. Uh, it was cornered to one application, but because of something, and I already mentioned the three of them. Number one is the advancement in hardware and in hardware, so the hardware become faster and become take more storage area. That's number one. Number two is drones, and which provides a cheap platform. And number three is the tools like artificial intelligence and image processing and computer vision that it never existed 20 years ago. Now let's go back to our slides here and try to tell you really what photogrammetry is all about. So, there is a definition here, which is you can enjoy reading the definition. I have a different one for you. So, do you guys know what does mean photography, not photogrammetry? Yeah? Photogrammetry, for now, it's a mystery for you. A mystery. You don't know what photogrammetry is. But I'm asking you, what is photography? Photography. Anybody knows what is photography? Oh my God, no way. No way. Photography is simply you hold your camera and then you simply click on the button. Okay. And so when you do that, do you guys know what's happening in the background when you click on the button? Very, very simple. You get an image. And what is the image? The image is simply a projection of a 3D thing on a two-dimensional surface. So in general, when you take a picture of your friends or a house, any object is a 3D. It has three dimensions. Huh? When you do take a photo and you do a photography, then you are simply projecting your three-dimensional object into two-dimensional plane. As simple as that. It means when we do photography, we are losing one dimension, which is the depth. Okay, we don't see the depth of things. Now, photogrammetry is simply, in a simplest definition, photogrammetry is the inverse of photography. Photogrammetry is the inverse of photography. And what it does, look at this picture, please. So here is a kind of a sketch where we have the reality. So we have the ground, we have roads, and we have the reality. And then let's say I fly an object, sorry, I fly a drone or fly an aircraft, happens to have a camera. We take some photos. And look at this. This is my 3D. And you can see we have up and down, up and down. That's a 3D reality. And then we take an image. So what do we get is we get two-dimensional representation of the ground called projection. That's photography. In photogrammetry, we reverse the process. We take our photos and we go through mathematical models, and we should reverse the process to create back our 3D. So think about it this way. Photography goes this way. You go from 3D reality to 2D image. Photogrammetry, it simply reverses the process and go from two-dimensional images into 3D reality one more time. And here we go. I have an example for you. So look at this. And I know none of you guys will appreciate this as I anticipate, because I know that because I don't have a tool to rotate this for you. But I want you to understand for now, and for sure we would have a software training where you will see that for sure. So the one on the left is a picture. The one on the left is a photo that we can take on with our camera. And the one on the right is a 3D model. And I know in this presentation, you don't see the difference, but I promise you, I promise you, when I process the data with you, I'll show you the difference. This one is a 3D and this one is 2D, okay? So photography is simply, you stand somewhere, you take an image, you project this 3D object into the image. Photogrammetry, we try to reverse. So we take the image and then create back our 3D model. As simple as that, okay? Now, let's talk about classification of photogrammetry, because you will see photogrammetry, although the idea is so simple, but we go into so many aspects of photogrammetry. Number one, let's talk about classification of photogrammetry. And look at this. Photogrammetry, we said we use images to create a 3D object of something, okay? Let me show you. For example, we can start with on the ground. So I'm on the ground. I'm not flying. I'm not having my camera. I'm holding my camera. either with my hand or I place it on a tripod, like a total station. Which one is better? For sure, the one on the tripod is better. Can anybody tell me why the image on the tripod will be better than handheld?
It can't move.
Yeah, if you hold the camera yourself, probably it will shake and probably it will affect the quality of your image. But if you install your camera on a tripod, for sure you get a more stable image. And by the way, even right now, this is not required because right now people they invented something called the gimbal. And look at the YouTubers. When you look at YouTuber, when they move around their camera, do you feel the image are shaking or you feel it very stable? Any help? Anyway, I watch videos like with YouTubers, and you know the cameras are very stable because of this new invention called the gimbal. It's simply when the image is shaking, then this gimbal will stabilize your image. Anyway, so that's one thing called terrestrial photogrammetry or close range, because your camera is very close to your object, very close. It could be maybe 1 or 2 meter, or maybe a few centimeter, or maybe 20 or 30 meters, but you are very close to your object. Is that it has so many applications, like by holding the camera and recording a small object. It can be like a statue or a small object like a shoes. Okay. Now the second option is we try to elevate our camera, because when we fly our camera, we get some advantage. Huh? When we fly our camera, make it far from my object, I get some advantage. And the advantages is we cover large area, because you guys know, huh? If I'm very close to my object, I cover a small area on the object. If I go back, then I cover more area. You guys agree? Do you guys agree if I go back with my camera, I cover more area?
Yes.
Yeah.
Okay, same thing here. So if you fly your camera, place it on a drone or place it on a aircraft that flies maybe 1 kilometer above ground, we get the advantage of covering more area on the ground. Okay, so we can finish our job faster. Okay, so we get into airborne photogrammetry. Airborne photogrammetry. You can see here we have kind of ranges even. We have ultralight aeroplane, which is drone. We can fly between 100 to a 300 meter. So that's called ultralight aeroplane or drones. And then even we can go past 300 meter up to 3 kilometers. Okay. And remember, we cannot fly a drone 3 kilometers. Nobody, why is that? Why cannot we fly our drone 3 kilometers above ground?
Because you have to control it with the remote.
Oh no, I'll tell you, my drone, it was expensive one, not really the $50 from Walmart. It was $2,000, and my drone can fly for 3 miles away from you, and you can do that horizontally or vertically. Okay, so the drones are very powerful in terms of communication with the controller, and it can fly for a very far distance. So there is a different reason here, because the drone is a tiny object and it's not really controlled by air traffic. So it can simply hit or collude with some other object in the sky. Guys, remember the sky is not, it's not like empty. Huh? Think about your street. Your street is very busy, correct? Same as the sky. There are, before the pandemic for sure, huh? Before the pandemic. So the sky was super busy, and if you fly your drone, it maybe hit some object, will put some people in danger, and that's why we don't fly our drone that high. So has to be an aircraft. Even for aircraft, we can fly between 300 to 3 kilometers, or maybe from 3 kilometers to 10 kilometers. All of those are still called airborne photogrammetry. Then finally, we can really put our camera very, very, very high in the space, not even in the air, in the space, like 600 kilometers or 1,000 kilometers above the ground. And in this case, there is no aircraft there. Okay, I think maybe a space shuttle or something, but it's a satellite, huh? So we can simply add satellites, and satellites, they have cameras, and those cameras, they can still take photos of the ground. Hopefully from this discussion, you can see we're getting into different application and different domain just because we simply change the distance between the camera and the object. Remember this, huh? Terrestrial or close range. Then the next step is airborne. And then the final step is satellite. In my class here, you will know a lot about every one of those classes and their applications. Now let's start with the close range. Close range. So as I said, my camera could be few centimeter or even few meter from my object. Anybody tell me what is my object in this case? Look up my screen. What is my object in this case?
The building.
It's a building, yeah, it's cathedral. And this is very, very old application of photogrammetry where you just have to stand and take some photos. And from those photos, we can create the model on the right. So the model in the right is simply, it's a CAD file that simply show you the front or the facade of the building. We do that for architectural documentation. So for all the buildings or cathedral, we take those photos. So we make a 3D model just in case if something happened to the cathedral, we can simply build it. Why we can build it? Because we have a 3D model. I think there is, cannot really remember, there was a very famous church in France, I think that was burned to the ground a year or 2 years ago. Do you guys remember this incident?
Yeah,
Yes.
Notre Dame.
Notre Dame, yeah, Notre Dame. I think it's one of the. I think it's the most famous cathedral. I think world, and the world was so sad. And the good news is we have a 3D model for the Notre Dame, and I think it's now. It's maybe they will build it sometime. Maybe they are waiting for fund or something. Okay, but the good news is we have a 3D model. Just luckily, we had a 3D model, and we can build it again. So we can use this technique for so many applications. For example, architectural documentation. We can use it even for deformation monitoring. So I can take some photos before and after, and I can find the differences in location to find deformation. Also, there is one important application, but it's not civil. It's not civil. Simply, it's about crime scene investigation and all those police investigation. What they do is right after the crime, so like when the crime is found, then a policeman will go and or men will go and take some photos, and then when we have so many photos, we can take them to the office and we create a 3D model. Sometimes if you have like an accident, a car accident, not really a fender accident like a small one, a big car accident, somebody is dead. We simply right away, the police will show, they will take some photos, record the scene, and they can do the analysis later on. Because otherwise, oh my God, if they take just like a very slow measurement using other technique like tape or something, then in this case, it will take forever. And to be honest, we don't have the luxury to do that. I remember a few times when the sea train was shut because the train hit somebody and the whole city was in chaos because of this accident. And that's why we need something that is very fast to do 3D modeling very fast. Okay, next is aerial photogrammetry, which is simply we fly, not really handheld or on a tripod. We fly our aircraft and we take photos of the Earth, and then finally we create a map. As I said, aerial photogrammetry was a standard method of creating maps. And to be honest, let me run this question by you. If I want to create map for Calgary, a map for Calgary, not for your house, a map for Calgary, I'm asking you, do we use total station or GPS or photogrammetry? You need to think about your answer, huh? I need to create a map for Calgary. It's a 50 kilometer by 50 kilometer. And I would like to make this cost effective. Should I use total station or GPS or photogrammetry?
GPS.
GPS, okay? So you want to hire 1,000 surveyor. They go to the site for a month. They have everyone which should have a GPS to simply measure every point on Calgary roads and
No, sorry, I
buildings.
thought it was just like a satellite taking pictures.
Okay, so
My
I
bad.
think now you know what I mean, huh? So I'm asking you one more time. What do you think? Which technique is the best to make a map for Calgary?
Is it the photogrammetry?
Photogrammetry is the way to go because simply you fly an aircraft at elevation maybe 3 kilometers. Every image will cover maybe 1 or 2 kilometers. You get your images and then you can simply process your data and create maps for entire Calgary very, very efficiently. And that's why here is my statement all the time for large scale mapping. For large scale mapping, photogrammetry was the way to go ever since. So ever since, if you want to create a map for something like Calgary, it was photogrammetry. But the new thing is that photogrammetry, it is not that anymore. You can apply photogrammetry right now, not only to a scale of Calgary, but even you can make build a 3D model for your house. And by the way, 20 years ago, that was not feasible, because simply 20 years ago, would you go to make a map for your house? Would you go and hire a pilot? Would you go and rent an aircraft to fly above your area and get your building to make a 3D model? What do you think?
No.
No, so here is my argument. My argument is photogrammetry ever since it was used only for large scale mapping, like mapping a large area on the ground. However, in 2020, photogrammetry broke this corner and become kind of viral. You can use photogrammetry for every scale you wish. You can apply photogrammetry in a scale of a single house or maybe a subdivision or maybe the entire Calgary or maybe entire Alberta. The difference is how far we fly from the ground. If we, with the drones, we can fly for maybe 50, 100 to 100 meters above ground. For aircraft, we fly few kilometers above ground. And the higher we fly, we cover more area. But photogrammetry right now, applicable on every scale you can imagine. Now, satellite photogrammetry is not covered here. I will have a different presentation for satellite photogrammetry where I give you a lot of information about satellite photogrammetry. Now, before we proceed, I want to make sure that you guys understand the beauty of photogrammetry, what can it offer you, and what are the kind of drawback of photogrammetry, what are the limits. You need to understand those, very important, because simply if you understand the limits of every survey technique, then you should be able to pick one or the other. Now let's talk about the advantage first, because there are so many of them. Number one, it's indirect measurement technique, and I call it here remote. Why this is super good? I'm asking you, when you take an image of something, do you have to touch this thing? Do you have to touch this thing? I don't think so. When you take an image of anything, you can be away and take an image. Is that good or bad? That's amazing, because there are so many applications where it is not possible to touch this thing, and sometimes it's even unsafe to touch this thing. But before I show you the examples, let's look at total station. In total station in general, do I have to touch the thing? Yes or no? In general, I know that some of you will say we have a reflectorless total station, so it can measure XYZ of points, which we don't have to bring a reflector. But in general, beyond the range of reflectorless total station, do I need to touch the object?
Yes.
Okay, and by the way, so in total station and GPS, both of them in general, you have to touch the object. Now I'm asking you, what if the object is unsafe? And some of you will say, what does it mean unsafe? What does it mean unsafe? It means if you send your surveyor, probably it will never come back. You know, there are so many applications of that. Number one, in a war, if you have a war, if you're fighting with someone, and if you fight with someone, I can tell you, maps is very important, because if you know map, it means you know location, it means you can shoot them, because you know exactly where your missile will go. Do you guys agree? Agree. Okay. So you don't have, I mean, if you fight with someone, you cannot say, send them an email and say, okay, we will send you our crew tomorrow to do the survey and we will shoot you the day after. Would you? I don't think so. Okay. So if something like in war, photogrammetry is the way to go. You can fly very far, very safe. You can make maps, And then here we go. Number 2 is we have some structures, for example, some old building that's maybe 1,000 years old, and those structures are about to fail. What is the best technique to do the 3D model? Photogrammetry or laser scanner. We don't have to touch the object because it's unsafe. And there are some areas which we have hazard. Sometimes we have a tsunami, and sometimes we have oil spill. What is the best way to create a map while it's unsafe to be on the ground? Is simply photogrammetry. So that's why photogrammetry being a remote, it's also a safe technique. Number 2, data acquisition. Is it fast or slow? Let me tell you, how long does it take to take an image? Any help?
Very quick.
Very quick. In less than 1 second, your shutter will have to open and collect the photo, and then that's it. We have an image. So data acquisition is very, very quick. Okay. Number 3, which is something you will not appreciate right now. I'm sure that you don't understand what does it mean, high density results. You don't understand that, huh? So please just believe me, and then I will show you that. I'll prove it for you at the end. So when I say high density, it means the data frequency or data is so much. We have so many points. When we do photogrammetry, we get thousands and millions of points. In total station, if I want to get millions of points, you know how long does it take to take million shot, huh? It takes forever. And that's why high density results, this is an advantage of photogrammetry. And that's why, look at the name, point cloud. Cloud. So we get cloud of point, millions and trillions of points. So this is advantage, and you will see sometimes it creates a problem when you have billions of points. But let's discuss this one later on. Number 4, it provides permanent measure of the object under study. What does this mean? Guys, when we use total station, we pick the points of our interest. Do you guys agree? So if we are interested in manholes, we send our helper to the manhole. You guys agree? In photos, are we selective? When we take a photo of something, are we selective? Are we being selective when we take a photo of one scene? Do we say to the camera, capture for me the trees, but not the building? We don't do that, huh? So the photo is a permanent record of everything exists at the time we take an image, okay? Next is the processing is completed in the office. Is that advantage? If I'm able to quickly take photos and go to the office and finish and create my map in the office, does this make an advantage for photogrammetry? Guys, please, I'm telling you, I'm so excited about the topic. I want you guys to interact because, again, this presentation could be as best as you can think of it, or it can be like very boring. Please try to think. I'm asking you, if I process all my images and create my 3D model in the office, is it that advantage of photogrammetry?
Yes.
Yes, it does, because simply I don't have to stay any time on site where it's very cold or very hot. I just go quickly to my office and build my model. Number, excuse me?
You can work from home.
Yeah, just like online. So you simply take your photos very quickly, go to the office, do the processing. Now, the results are rich with color information. And this is something I know that you will not really appreciate at the moment because you don't know what do I mean. But when you survey the points in total station, do we get any color information or we only get XYZ? We get only XYZ. If you use total station or GPS, you only get XYZ for the surveyed point. In photogrammetry, since we're using or estimating our XYZ from photos, and photos, they are rich with color information, so we also get color for the point. Last one is the advantage is photogrammetry is efficient for large area and a small area. And this statement is only true only now. 30 years ago, this statement was wrong because photogrammetry was efficient only for large area. Small areas, we don't use photogrammetry. Now, when it comes to disadvantages, we have only few of them. And actually, they are not really in general disadvantage, but sometimes we do get them. One is photographic processing delays. Do you guys, by any chance, any of you have an analog camera, a camera that has a film? A film, okay?
I have a Polaroid camera.
Okay, great. So those cameras, they are very popular like years ago. Right now, people, for convenience, people use digital camera where simply your final output, your image, right away, it's in digital format. So you can simply upload it to the internet. You can send it by email. You can store it on your OneDrive, blah, 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 all of those. So this is digital camera. Analog camera, it's not like that. It has a film, and this film has a material which is sensitive to the light, and then we can store our photos on those, negatives. Okay. If you remember, what does it take you to create your image using analog cameras? You need to wait until you chemically process the film and create your photo. And then one more disadvantage of photogrammetry, the analysis takes long time. And I know some of you, again, don't appreciate what does it mean. As I said, please be patient. All of those will be cleared shortly. The processing and creating the 3D model, it takes a longer time because it needs a higher processing power. It means I need faster computer. In our class, we will start, not today. I will ask you to download some software today, but we sometime probably next week we will start processing some data, and what you will see is it requires more time. And I'll give you an example. I myself processed 50 images, only 50 images, and it took my computer 1 hour. 1 hour. So the computer worked hard for 1 hour until I get my 3D model. Okay. You know what? Probably it's a good time to show you, this thing. Okay. I want to get you guys excited about the topic because the topic really, really, really is super exciting for myself and even for my students. So do you guys see my screen?
Yes.
Okay. So this thing on my screen, okay, this thing on my screen, this is the software that I will teach you, which is very simple. Anybody I seen this is somewhere in Calgary? Anyway, I know that we are in the pandemic and people, they don't go much outside, but if you have been to the Calgary downtown in TD Square on the very top floor, what do we have on the very top floor of TD Square?
Dovian Garden.
Yeah, the Devonian Garden. And if you go to the Devonian Garden, you will see this wooden mask there. I'm asking you, is that a photo or a 3D model?
3D model.
That's a 3D model, and this is something I've done myself. I was in Devonian Garden like 2 years ago, and then all of a sudden I said, okay, I want to teach my students photogrammetry. So I got my cell phone camera. I took about 47 images, and I built a 3D model using the software that I will teach you next class. Okay, and you know what? To build this model, it took my computer 1 hour for about 50 images. 1 hour to build this 3D model. And the surprise is something you will be surprised when we fly our drone and we have a large scale project. I have heard of some project. The number of photos is 24,000. 24,000 images. Can you imagine? 24,000. And by the way, the relationship between the time and the number of image is not linear. What does it mean? It means, what if I have 100 image? Do I process in 2 hours while 50 images in 1 hour? That's called linear. No, the relationship is not linear, which means under 24,000 image, probably I need few days for my computer to work very hard to build for me my 3D model. But I want you to look at the beauty. Look at the details of my 3D model. Do you see that? Do you see the cracks and the teeth and the eye? You can see I got very, very detailed model. Anyway, we will have the exercise and explain for you what to do. But for now, all I'm trying to say here is that photogrammetry, it requires a long time. But the good news is I myself will have to do almost nothing. You will see that. The software will do everything on your behalf. And this is super good. And it was not like something that we can do 30 years ago. Okay? I will say something that you will be proud of. You know, the software to do that, to create the 3D model, the software will simply have to look through the images and do the matching. We'll have to, for example, pick one point in, for example, this point here on the eye, and we'll try to go through all the images and we'll try to say, okay, where is this point in the series of the image? This is something a human can do it in a second, okay? Any kid, if you give 2 photos for a kid and you show something on the left image, the kid will right away say, okay, here is the same thing on the right image. But for the computer to do that, it was something very, very hard. And what will make you proud is that this is due to a Canadian professor. The Canadian professor in about year of 2000, it's 1999. His name is David Lowe, and he is a professor in Vancouver in UBC, and he created an algorithm that can simply do the matching very, very accurately. Okay. So the software will have to look through all the images and simply find all the conjugate points to find or build the 3D model. The last disadvantage for photogrammetry, which you never felt it, is that it cannot do a layout. That's really a big thing. Huh? In surveying, we have 2 things called surveying and stick out or layout. Stick out means I have a point of known coordinates. I want to place it back on site where it should be. Photogrammetry cannot do that. And that's why even photogrammetry is amazing and it does a very good job, we'll still need total station. Okay. Probably it's time for a break. Okay. So we'll take 10 minutes a break. I'll get some rest and we'll see you guys in 10 minutes. Thank you so much.